probably spent a day doing just what you're doing here. Mucking around, going,
a week or two, possibly.
what goes? How does it work?
Yeah. Okay, so that's what he would do, is he'd have this one running off, and then that's not the only place. That's just the highest place to store water. So then down lower, because the landscape goes like this, and like that again, and then lo and behold, we have another one down here. This is not the key point. There's only one key point in your landscape. There's only one key point. So what he would do is he would have another dam down here, which turns out you get a much larger volume of water stored, because we took this material here to make the dam. And there's the ridge. You get a much larger volume of water stored for earth moved. So this is a much more efficient dam from a cost-effective perspective. The flatter the landscape, the cheaper the water. Okay? And that is this. If that's the dam wall, and this is the amount the water backs up, when this length is shorter than that length, you have a very cost-effective dam.
So you're saying if it was steeper, you'd have to build this side up higher.
Yeah,
so
it has to come up higher, right up here. See, we just moved this little bit of earth. We moved a large volume of earth for very little water stored, and we moved in proportion water stored for earth moved. This is much smaller. Right. And what you would do is you would then, if this water is running all the way out here to irrigate this ridge, he would have another diversion drain that came in along here, so that the only thing he lost as water moved through the system here, once it saturated the soil, was the energy value of water falling from here to here, but is 100% efficient at conservation. So getting as much water as he can into the soil because of the keyline plowing, right? But like maximum storage because of the fact that he's not losing it. And if you kept on going all the way down to the river valley, and you could just trip, trap, and store water all the way through. And then we have the other valley on the other side, so it could have dropped in right here, and we could put another dam right there, and then spilt that one in there, so you could just drop water. You could even have water up there, because that one's higher. Right, because the key point is up there, if this was our whole system. And so the beauty of this is that one person could go out into the landscape, open a gate valve. But before he opened the gate valve, what he would do on this, he would go put a big canvas sheet and lay it in the bottom of the ditch, and then across the ditch he would span it with a shovel handle or something like that, and wrap the canvas over that so that supported it. So when the water rushed along, it would hit that, back flood, spill over in water. While that one was watering, he could run down and put another flag in, another canvas flag in, pull this one, and it'd run down and it'd spill over there, and it'd stop spilling on there, and just sequentially, one person in just a few hours could water hectares and hectares of land. And not only that, the land was opened up, right, to accept that water and build soil for a rotational grazing system. And then sell the animals, which only represents 10% of all that productivity leaving year after year. It's good. It's definitely good. I want to show you, I'll be right back, I gotta get something for my truck.